Want to maybe talk a little bit about your background and sort of growing up?
I grew up in India. I did my undergrad at an IT. Yeah, and that was in electronics and communication engineering. But even when I was like kind of like doing my undergrad, I think two things kind of like attracted me quite a bit that still like plays a huge part in my professional life today.
Mm-hmm.
One is like even though when I was doing my undergrad, it was like pre-deep learning. Like
Mm-hmm.
we were just um, imagine it happened in 2012, and I was like in my final year back then.
Mm-hmm.
But even then, it was like very clear to me that deep learning and AI are going to be like the next big things.
Mm-hmm.
And so I kind of like always really wanted to like work like very much in that field.
Mm-hmm.
And so for my grad school, I like made a very conscious decision to like move over from like an electronics background
Mm-hmm.
to computer science and AI.
Mm-hmm.
And I think that has like obviously paid off quite well over the last 12, 13 years.
Mm-hmm.
And then the second thing is just like the context of like, growing up in India,
Yeah.
like, in like parts of the country that I grew up in,
Mm-hmm.
like going to see a doctor was like a pretty big challenge.
Mm-hmm.
So I knew kind of like people who had like not seen a medical doctor in their entire lifetimes.
Mm-hmm.
And so it almost always felt like this is one of the root node problems that
Mm-hmm.
we should be striving to solve because it should not be so difficult to like go and see a doctor because again, I think there are different issues over here, but like my feeling was that if we were able to do like a very good job at it, then
Mm-hmm.
we'll be able to unlock like more, just like raw human potential to do like greater things in the world.
Mm-hmm.
And so like I was always like very passionate about like working on healthcare and healthcare access. And so even in my like final year in undergrad,
Mm-hmm.
a few friends and I we were building this app called Ask the Doctor Anytime Anywhere.
Mm-hmm.
And so the kind of the name tells you what we were trying to do, but I would say like the technology and the machine learning and AI needed for such a thing to exist was just not ready back then.
Mm-hmm.
Um, but I guess like if you fast forward like a decade right now and where we are,
Mm-hmm.
with all the amazing LLM-based models, reasoning models, I think we're in a position where we can really have that vision come true, where like medical expertise can be like really democratized. And so I would say like that's been like the running off arc of my career over like the
Mm-hmm.
last 6 years, especially at DeepMind.
Mm-hmm. Awesome. So, you were an undergrad at NIT Tricky, like we sort of talked about. And, while there, you were sort of involved with a few different things. I'm going to say, I think you had a few different internships that you had. Were involved with the University of Bonn doing research there. You did some research at IT Madras. Maybe tell us a little bit about some of the maybe notable parts of your experience at NIT, and then just sort of
Okay.
getting into, your time at UT Austin, what motivated that.
Yeah. Okay. I mean, that's a pretty far jog
Yeah.
down the memory lane over here.
Yeah.
Um, I think for me, like the undergrad experience was very interesting because it was like kind of like the first time I was going like really far away from my home and from my parents, and
Mm-hmm.
so I was going to a city which was literally like 2,000 kilometers away from where I grew up
Mm-hmm.
in the eastern part of the country.
Mm-hmm.
So that was obviously like the first big step and change. And I mean, Trichy is kind of like this interesting place where like half the students are from like the local area,
Mm-hmm.
the state, and then like the rest of the students are from like different parts of the country.
Mm-hmm.
And so, yeah, I mean, every like during like every festival or like every holiday, you would see like most of your friends like go away to their homes, and then you would be left back alone in your like hostel in your rooms.
Mm-hmm.
But again, that was kind of like an interesting experience because that just gave me like a lot of strength and like a lot of time to like pursue passions and things like that.
Mm-hmm.
And then the second thing is just like in some ways like the bonds that you form during your time over there, especially in like hostels where
Mm-hmm.
again I wouldn't say like back then like at least that college didn't have like the best facilities.
Mm-hmm.
So like there would be challenges with like water and electricity.
Mm-hmm.
Food wasn't the great, but then like you had this community of people with you, like who were
Mm-hmm.
like growing up with you and like trying to figure that out and solve those problems with you.
Mm-hmm.
And then you form these very strong connections. And for me personally, at least, like some of the friends that I formed when I like first met them during my undergrad, they're still my friends right now. Like we're all living in the same street. We hang out like every now and then. We like do projects together and things like that. And so,
Mm-hmm.
yeah, it's just that like I think like those experiences, those are the best times to like make connections, like long lasting friendships.
Mm-hmm.
And then again, from like a learning perspective, I think it was pretty great. And like obviously, like the focus was on like electrical engineering topics, but
Mm-hmm.
it allowed like the freedom to like explore like machine learning and robotics and things like that.
Mm-hmm.
That quite helped me. gave me the exposure that I needed, and then allowed me to like, and gave me the confidence basically to like, switch over to pursuing computer science and AI during my grad school at UT Austin.
Mm, awesome. So, like getting into the decision to go to grad school, I'm sure part of it was, to come to the United States and work on and sort of pivot from electrical engineering to computer science. Maybe tell us a little
Yeah.
bit about sort of the motivation and, your experience at UT Austin, some of the work that you did there, and then sort of how that started to bridge into your time at Meta.
Yeah. Again, I think like it was a very interesting time in the field. Like,
Yeah.
I mean, I was like, I mean, like just as soon as I finished my undergrad, like that summer, I remember spending a lot of time like digging through two courses on like Coursera,
Mm-hmm.
and I think it was there was another platform called EDX or something like that at that
Mm-hmm.
point of time.
Mm-hmm.
So one was Professor Andrewing's like famous machine learning course,
Mm-hmm.
the one of the early versions of that, and then another one was again like on machine learning, but this time from Professor Yasser Abu Mustafa at Caltech.
Mm-hmm.
So that like really got me into the field, and I couldn't wait. I mean, I was like, trying out these models and algorithms,
Mm-hmm.
just pushing how much I could. And this was all on the laptop. I mean, like these are like
Mm-hmm.
small models that you were training back then. But yeah, it just gave me like a lot of like interest and excitement in general, just seeing
Mm-hmm.
like what you can do with these systems.
Mm-hmm.
And then, I mean, the other I guess aspect was like UT Austin is like a very traditional school.
Yeah.
So back then, like even though like you would find like deep learning courses at Stanford,
Yeah.
which are being taught by like Andrew Ng or Chris Manning,
Right.
like at UT Austin, like the machine learning courses were like more traditional and old school. Like the courses would be on like graphical models or like
Mm-hmm.
um, probabilistic theory, Bayesian networks,
Mm-hmm.
and like old school like neural networks.
Mm-hmm.
And you had some like very like pretty amazing faculty over there.
Mm-hmm.
And I think I was kind of like fortunate and lucky because that actually gave me like grounding in like the traditional ML concepts
Mm-hmm.
while deep learning was taking up, and so that
Mm-hmm.
allowed me to like in terms like in some ways like bridge and internalize, because I think that is the foundation.
Mm-hmm.
Like people tend to like ignore these concepts or these ideas in deep learning,
Mm-hmm.
but they oftentimes become very important when you're trying to like solve like really complex challenges or like understand like why algorithms work in
Mm-hmm.
certain ways and things like that. And you can always like bridge and marry together ideas, and that helped me quite a lot. And then I think like at Meta again, I was like very lucky to work across like problem domains. And I would say like before transformers came along, like each field had like maybe its like own architecture. Like
Mm-hmm.
vision models would be like ResNet based.
Mm-hmm.
NLP would be like ConNet before transformers, and then RNNs and LSTMs came on. And then yeah, speech was again like when I first started working in speech, like only one part of the system was like a deep learning model, that was like the language model. Later the acoustic models also became that, but then we also had these hybrid networks where like parts of the system would be like GNNs or HMM based, and then other parts would be LLM based. So again, like exposure to a lot of different architectures, and also the platform was like constantly evolving. And so
Mm-hmm.
at Meta, like exposure to Torch, like the Lua Torch version, and later
Mm-hmm.
on with PyTorch. So when you're seeing that, and also like bits of Cafe here and there because we were trying to
Mm-hmm.
productionize. So yeah, so I think what it really enabled was like just the exposure to a large number of problems and a large number of ideas.
Mm-hmm.
And then also like being actually a lot more closer to like the base implementations.
Mm-hmm.
And I think that gave like extremely good grounding and fundamentals for me,
Mm-hmm.
which has like served me really well to this day.
Gotcha. So maybe tell us a little bit about your internship at Qualcomm, where you were working on, multimedia R&D. And this was obviously a long time ago.
Yeah.
Maybe just a little bit about that experience, and then, your first few years at Meta. Obviously, you were there for a little while, like around 3.5 years or so. Maybe tell us just a little bit about a few of those experiences. So it's like your first year. You're out of UT Austin, Masters in Computer Science. How did you, what team were you on? Like, how was that experience?
Yeah, sure. So yeah, I think at Qualcomm I was working on actually doing like traffic sign object detection,
Mm-hmm.
because Qualcomm back in the day was trying to build these driver assistance systems and software for that.
Mm-hmm.
And so as an intern, I was trying to like prototype one of those systems that would maybe someday go into the car.
Mm-hmm.
Um, it was a really cool experience because like in grad school or like what you can do in your spare time, those are like toy problems.
Right.
Whereas this was like an actual real problem.
Right.
And I had to pretty much do it like end to end, like define the problem from scratch, like
Yeah.
get the kind of data sets, then look into like the kind of like platforms and like libraries to use over there. again, like define the architecture, loss functions, optimize, and then also like optimize the implementation so that it can like run in a real time manner that you can then demo to like the execs over there. And so it was like a very fun experience for me. Like I was given the responsibility, and that was like very, I would say, empowering because it allowed again me to, as an intern, allowed me to do like a lot of things and have like a lot of learning in that 3 month period. So yeah, I had a fantastic experience over there. And then again at Meta, as I was saying, I was part of the applied machine learning team initially, and then moved on to Facebook AI research. Again, like it was a lot of fun because I got to like work at the intersection of like research and production. And so the goal was not to always like do pure research, but also like to translate them into like into product impact and like into like relevant business services over there. So again, that gave me exposure to like the considerations that you have when you're like shipping something from research to production, like things around like latency and throughput and like cost of serving and things like that. The metrics that you try to optimize. And it was very interesting to learn in particular that sometimes like the metrics that we optimize as like researchers can actually diverge quite a bit from like the business specific metrics that you care about. And so then you have to like start engineering like surrogate metrics and like proxies to make sure that you're capturing that as well. Otherwise your models are going to diverge when you deploy online. And then you run into issues like, for example, when you deploy, there's like a drift that happens. And so how do you keep on like monitoring and then sampling the right kind of like production traffic and like retraining your systems and redeploying, and then at what cadence you do that? So yeah, it was like, I think, a fantastic experience, I would say. And then the opportunity at FAIR, obviously, to like work with some of like the most brilliant researchers in deep learning, again, was just like an incredible like learning and humbling experience.
Awesome. So I guess like, are there a few products that you want to talk about that you worked on? So you sort of mentioned this intersection of research and product, maybe to the extent that you can talk about maybe some of the lessons that you learned sort of at that intersection, or maybe some of the products that you worked on and models you worked on.
Yeah, I mean, like these were all like very, I would say, not like long running projects because being like I was in a team where you constantly like shifted like priorities, and so but yeah, I think like for example, just getting like the exposure to like ship some models into production and like newsfeed or like search. Again, these are like surfaces with like billions of users, business critical surfaces, and so like all the considerations that go into that. And like and also just the learning, right? So for example, like I would be developing like a new method in isolation from like probably the hundreds of other researchers who are also trying to like improve metrics on that surface, right? And so you can have like your own local test sets that you iterate on and you try and improve. But then as soon as you start thinking about doing like a live test, you are almost like competing with like maybe like 10 or 15 other methods that are coming in during that quarter. And so like everything is like put together, and then you don't know which one works well or which one doesn't work well. Sometimes they may be additive, but sometimes they may not be. And so it's like, yeah, again, that was kind of like an interesting experience because you have to kind of like coordinate and like kind of have like an understanding of what's going on. But sometimes the system is like so large and so complicated that you can't like even like guess what would happen. So yeah, I would say it was just like a fascinating experience. And also like I think as a community, everyone was like trying to get to grips with like large scale machine learning. And neural networks and deep learning. And so I remember like the first time when like the algorithms underlying like newsfeed and ads, they kind of like became like fully into like neural networks based rather than like traditional ML model based. And there was like a lot of like hesitancy, I guess, at that point of time because it was like such a big architectural shift. But then like as soon as you deployed and like allowed the traffic to like stabilize, you saw like such huge lifts in like performance that was like incredible. And so so when you see that like across like business critical surfaces, but at the same time you're seeing all these like research benchmarks like being broken through, it kind of became apparent to me that this deep learning thing is going to stay, even though there wasn't that convergence that we're seeing in the field right now with like the transformer architectures and with like say PyTorch and like JAX. There was still like multiple different frameworks lying around, multiple different architectures, multiple different ways to do things. And like the different topics or domains were still siloed, but like the ideas were kind of like the same, like data and compute when put together like in an intelligent manner, they're going to be like extremely beneficial.
Got it. So it seems like at Meta you weren't really working on medical things specifically, but then
Yeah,
maybe when you were you sort of like an ad hoc team where you're sort of depending on different features that are important across, like you mentioned, newsfeed or Reels or really any of these sort of pages, you're sort of helping with the ML. So you sort of reconnected back with your roots in some sense and like some of the work that you had done earlier on in sort of healthcare back at Google. When you
yeah,
joined in like May 2019, and now you've been there for around 6.5 years or so. So I guess
yeah.
like walk us through a little bit of sort of like what motivated you to join Google and DeepMind. And, I'm sure first Google Research and later on DeepMind.
Yeah.
And some of the work that you did there. Are there any sort of highlights of that journey that you want to share?
I think the motivation was kind of like very straightforward.
Yeah.
So as I said, for me, like healthcare access felt like a root node problem.
Right.
And I really wanted to see if I could like, contribute towards that.
Yeah.
And I think roughly around 2016, 2017, I saw these papers from Google
Mm-hmm.
showing that computer vision models could work really well in medical imaging. Like they had
Right.
like this paper on detecting diabetic retinopathy from like fundus
Right.
images.
Yep. Yep.
And that was like very influential for me because my uncles back in India and Tamil Nadu used to like run these eye camps like yearly
Yeah.
where they would get like all the people from like the local villages to come
Yeah.
in and like give them like free doctor checkups because
Yeah.
if you don't like detect it on time then you're going to
Yeah.
have like blindness. It's such
Right.
an easy thing, but you
Yeah.
just have to like diagnose it at the right time so that you can treat it.
Yeah.
But like we knew like so many people who did not do it, and like my uncles were like kind of like try to do it with like whatever like human capacity that they had.
Yeah.
But technology and AI can like take us much further, right? And
Mm-hmm.
so that was like super inspiring for me when I saw that. And then also like there were other papers on like mammography and breast cancer detection.
Mm-hmm.
So that inspired me, and it was very cool to see like Google investing in such topics,
Mm-hmm.
which are maybe like not core to the business, right? Not
Mm-hmm.
core to search, for
Mm-hmm.
example.
Mm-hmm.
And so yeah, so when I had the opportunity to join, I mean, I was like, it was kind of like a no-brainer.
Right. Yeah, it totally makes sense. So there's a few different research papers that you've worked on. Maybe first we can just ask you, like, are there any sort of high level contributions that you want to mention? And then maybe we can dig a little bit deeper into some of your exciting papers.
Yeah. Again, so when I came into Google, like,
Mm-hmm.
I think it was again like the first few years were like a lot
Yeah.
of like learnings and failures.
Right.
Coming from like an environment like Meta where you're like shipping models to production like
Of
literally
course. Yeah.
every month,
Yeah.
like super fast moving.
Mm-hmm.
And then you come into Google, which is generally like a little bit slower,
Mm-hmm.
but also like you're coming into like a domain in like healthcare
Mm-hmm.
where it's like, yeah, just a lot more challenging. And
Right.
we did not necessarily have like a product surface to ship and like learn from.
Mm-hmm.
So like a lot of the research was kind of like done in isolation. Um, and um, and I guess the other thing was like it became like the first few years it kind of like was quite apparent that like the previous generation of like maybe supervised models that we were having,
Mm-hmm.
um, they were not maybe like cut out for the task.
Mm-hmm.
And so they kind of like lacked like the reliability, the generalization,
Mm-hmm.
the uncertainty estimation, and like calibration that you really need to like thrive in like a safety critical domain like healthcare.
Mm-hmm.
And so yeah, I mean, we would always get like these nice research papers that would show like strong performance on like some given tested in like on like a task.
Mm-hmm.
But then as soon as you like take it to like a slightly different distribution, that like the performance would start
Of
dropping, and
course.
you really don't want that like in healthcare,
Mm-hmm.
right? And so and it became like the first few years it was always like uncovering all these issues.
Mm-hmm.
And then like again like all these models are like producing like point estimates and things like that.
Mm-hmm.
And then like if you're deploying it in like medical workflows and if you are having these systems interacting with doctors,
Mm-hmm.
they I guess don't have enough time to understand like these confidence intervals and like point estimates from these models.
Mm-hmm.
So they don't have like a good intuition as to how much to trust these results.
Mm-hmm.
So you need systems that are like far more interactive in nature.
Mm-hmm.
And back then we just did not have them.
Mm-hmm.
And so yeah, so I would say like the first 3 years it was kind of like lots of learnings and lots of failures.
Mm-hmm.
But then I guess like it was probably like around like April 2022 when I like saw like the first versions of our like language models, which were like the precursor to Gemini, which was like the Palm-based models.
Mm-hmm.
And it was still like very early, but like I could see like these signs of like few-shot learning and generalization and interactivity, which
Mm-hmm.
clearly convinced me that that is the future. And so like my like very good colleague and like maybe like co-chief conspirator in like all my work at Google, like Dr. Alan Karthikeyanam, I think he was also visiting from London.
Mm-hmm.
And then we just had like dinner that night, and like I was showing him the demo, and he was like, "We have to absolutely pivot and start working on language models.
Mm-hmm.
And this was before ChatGPT.
Mm-hmm.
So this was kind of like, in some ways, like heretical.
Mm-hmm.
But we decided to do that, and like to get funding, we put together like a moonshot, which is like a program that we have in Google Brain to like go after like crazy ideas.
Mm-hmm.
And thankfully, we had like enough supporters and people who come in and join. And then yeah, I mean, I think that's like in some ways like the beginning of like the modern era with LLMs in healthcare, because as like soon after ChatGPT came out, like I think in like a few weeks, we had our paper on MedPalm, which was like the first AI system to get like passing level scores on like USMLE style questions.
Mm-hmm.
And then 3 months later, we followed it up with like MedPalm 2, which like reached expert level performance.
Mm-hmm.
And so that's like the beginning of this journey.
Mm-hmm.
And this journey was more towards like, I would say, general systems in medicine, like systems that can almost like act as a doctor. And so like, the MedFarm and the MedFarm 2 results, I think they gave us like a lot of confidence that this journey is possible. And then so we started like a new project called Amy, where over the last few years, we've had like a series of papers that have been like, I would say like stepping stones towards this vision of having like an AI co-physician or like an AI co-doctor.
Mm-hmm. Awesome. So I guess like maybe tell us a little bit about the implementation of MedPalm and MedPalm 2. So I mean, it almost seems like you have these three different, sort of MedPalm versions. You have your original MedPalm, you have MedPalm 2, then you have
Yeah.
MedPalm M. And
Yeah.
so maybe tell us a little bit about the evolution from, 1 to 2 to M.
Yeah, I would say they follow like the evolution of like the palm system as well.
Yeah.
Um, so like, yeah, I mean, MedPalm was based on like the original palm, but then in order to like, specialize and align it to the medical domain, we use a strategy called prompt tuning, which keeps like most of the models frozen. And Palm was like a very large model. I don't fully remember it, but it might be like 540 billion. So that's like a lot of compute that's needed to like train. And then also we didn't quite have like as much like language tokens in the medical domain as we do right now. So we were kind of like relying on like open source data sets to do that like super like fine tuning and alignment. And so for us, it made a lot of sense to do this technique called prompt tuning, which is just essentially like having these adaptive weights associated with the prompt that are like continuous and dynamic, and then you kind of like update them, but like keep the rest of the model frozen. And then the way I like to think about prompt tuning is it's like we're working under the assumption that because like Palm and other language models are trained on like large scale internet corpora, what we assume is that they have already seen like a lot of like medical information. So it's like a giant library. Right. And so it's like organized with all these shelves, and like some shelves are like, corresponding to like physics and chemistry, but there's also like a shelf corresponding to like medical books. And so what prompt tuning to us at least does intuitively is like at inference time, it basically like is like switching the lights on or like, flicking on the torch and telling where to look for, like where is the medical section in your like in the space of parameters that you have. And so that just helps the model like, better, more reliably like extract out the information from like the space of like knowledge that it has encoded in its parameters, and then like come up with the right answers. Obviously, it does a few other things like teach style, but I think that's maybe less important. But the more important aspect is just like biasing the model towards this domain and like making sure that it's like using whatever knowledge that it has learned properly.
Awesome.
So that was MedPalm. I think with MedPalm 2, the key innovations were actually like I'd say like again like supervised fine tuning was fairly early, like instruction fine tuning with LLMs, and so that was like the big difference. We got some little bit more data, and so we were able to do that. And then I think a lot of the innovation in that paper was actually on evaluations. Like there was like a lot more comprehensive evaluation rubric that we had that clearly assessed the capability of these models for like medical question answering, especially when like compared to physicians. And then we also had like a benchmark on like quite a relevant like clinical task, which we collaborated with Stanford on. So it was like a real world informatics consultation task. And yeah, I mean, the model was showing promise over there. And so I think those were the key innovations. And then MedPalm, I mean, I mean, you've been working on radiology report generation and things like that. I also did that before MedPalm. And so we all know that like, medicine is like inherently like a multimodal endeavor.
Right.
And so the question was like, okay, like how do you move beyond like pure language models to like more multimodal large models? And again, just before MedPalm, like the robotics team at Google, they had like this model called like Palm E, like Palm embodied. And they were able to like, bring together like images and like sensors from like the robot and like embed that into the same space as these language tokens,
Mm-hmm.
and then do decoding on top. And
Mm-hmm.
so you kind of like borrowed that architecture, but then threw in like a lot of like multimodal medical data that we could get access to.
Mm-hmm.
And then we trained like this new model.
Mm-hmm.
So yeah, again, yeah, that was kind of like the key innovation. And I think uh, I guess the most interesting result was, I think this was the first time like someone like showcased like a truly generalist model,
Mm-hmm.
like one single model without like any kind of like change in parameters.
Mm-hmm.
It's able to like not only do like medical question answering, but also like solve like genomics based tasks,
Mm-hmm.
do like radiology report generation, like
Mm-hmm.
interpret like the dermatology skin images.
Mm-hmm.
So yeah, I think that was like pretty cool. But again, like it was like still very early, I would say. I think these days now
Mm-hmm.
the models have progressed a lot more. Um,
Mm-hmm. Yeah, definitely. I think another one of your sort of like interesting pieces of work is this AI co-scientist paper that you had,
yeah,
titled "Towards an AI co-scientist." I think this one's
yeah,
a little bit more recent. I want to say it was on Archive in February 2025. Want to maybe tell us a
yeah.
little bit, just give us a brief overview on sort of what you were talking about here?
Yeah, sure. Yeah, I think this work actually has its origin
Yeah.
in like the MedProm paper.
Mm-hmm.
So like after MedProm was published in Nature,
Mm-hmm.
like my good friend Tao and I, we went to Stanford to give a talk on that work.
Mm-hmm.
And right after the talk, like there was a professor at Stanford, Dr. Gary Pels,
Mm-hmm.
who kind of like walked over to us and told us that your language models are great and you're using it for like these USMLE style questions.
Mm-hmm.
Maybe we can use it for like more interesting tasks.
Mm-hmm.
And like his idea was that again, because these models are trained on like large quantities of like biomedical and scientific
Mm-hmm.
software, they might be able to like make like interesting hypotheses about like, for example, causative gene factors for like different
Mm-hmm.
phenotypes that are observed in the world.
Mm-hmm.
So yeah, it was kind of like an interesting hypothesis, and so we started like working together with him, and even with like our palm-based models, we started getting like some interesting results. And so like Gary had this, and I trying to like study like rare types of like hearing loss, like
Mm-hmm.
genetic variants of like hearing loss. And so we were able to use the model to like come up with like a hypothesis for what genes cause them. And like Gary validated that using like CRISPR knock-in experiments with like mice in his lab.
Mm-hmm.
And that worked well. And so it was like one of the first examples of like AI-assisted genetic discovery.
Mm-hmm.
And then we were also able to like generalize that to like more complex cases in like humans, like with human variants of unknown significance,
Mm-hmm.
with our like early versions of Gemini models.
Mm-hmm.
Um, but kind of what became apparent to us that if you were to use these LLMs in like a very like naive manner,
Mm-hmm.
like just get these models, or you just give this a prompt to like predict like the causative gene factors, or like give me a hypothesis for this,
Mm-hmm.
then there's yeah, I mean, sometimes the model you might luck out and the model might like give you like some nice answers, but oftentimes it's just not reliable. So even though like the knowledge exists, like extracting that out is like a very complex thing. And so the question for us was, okay, like how do you make this like more reliable?
Mm-hmm.
Because like to get that like one interesting hypothesis that Gary validated, right? Like we had to like literally sample like thousands of times in the model, and then Gary was like, I mean, he was like patient enough to like say what was rubbish and
Mm-hmm.
like discard them and like take the best possible one.
Mm-hmm.
But our question was, okay, that should never happen. Like when the model is actually producing like an output or an answer, it should already be very good and it should be fully calibrated. Like it should have like very good like reasoning around like uncertainty,
Mm-hmm.
the feasibility of the idea, the novelty, etc., etc.
Mm-hmm.
So that was kind of like the goal. Like, okay, how do we engineer AI systems to really like take like extremely complex and open-ended problems,
Mm-hmm.
like and think about them for like maybe like days and weeks if needed,
Mm-hmm.
and then come up with like these very well calibrated like solutions and hypotheses towards solving them.
Mm-hmm.
And so yeah, that was like the core question or challenge. And then yeah, and then I guess like the other thing to point out is like we were not really trying to like automate science or like train AI scientists.
Right.
Our interest was more in um, like just looking at like aspects where we could really like augment and give scientists superpowers.
Mm-hmm.
And we felt that LLMs could do that with like large scale like literature review and summarization, coming up with like hypotheses, coming up with like research plans and experimental protocols. And so that's what we focused on, and that's what we continue to focus on with the co-scientist.
Mm-hmm.
And yeah, I would say like that was kind of broadly like the goal.
Mm-hmm.
Yeah, and then like we had like a bunch of different evaluations in the paper.
Yeah.
Some of them were like more benchmark driven, and they essentially show that like as the system spends like more time in like thinking, the quality of the ideas keep on like getting better and better, and so that's like a very cool result.
Mm-hmm.
Um, and But then we also had like a bunch of these real world validations in the paper where we showed that like hypotheses from the systems, when you actually followed it and ran like real world experiments in laboratories, we got some really cool results. So, for example, we were able to like identify like a promising drug that could be repurposed for this very rare form of cancer.
Mm-hmm.
We did something similar for like liver fibrosis. We had like the system solve like a very complex, come up with like a very complex hypothesis related to like how antimicrobial resistance propagates. And so
Mm-hmm.
yeah, so those are all like cool results. But maybe the last thing I want to very quickly point out is like the system itself was like to get to this level of like reliability and like this ability to like think without like mode collapse and like
Mm-hmm.
falling into I guess like coming up with like trivial ideas which would otherwise happen. We came up with this like very nice multi-agent architecture that had like
Mm-hmm.
a team of agents which kind of like cooperate but also compete.
Mm-hmm.
And it has these interesting dynamics and like information flows and natural language feedback that
Mm-hmm.
really allows it to like come up with these like very strong hypotheses.
Mm-hmm. Awesome. I think one of my favorite papers that you wrote is titled Towards VQA Models That Can Read. And this one was a little while back. I mean, we sort
Yeah.
of like went over some of the work that you did. I want to say that this is back when you were at Facebook AI Research. Maybe
Yeah.
give us like a brief overview of this paper and some of sort of the key contributions.
Yeah. Okay. That's almost like 10 years back right now.
Yeah.
But Yeah, I think for that one, I think earlier in the summer in 2018, like we had a model that we had like entered into like the VQA challenge, which
Mm-hmm.
was I think organized yearly at CVPR if I'm not wrong
Mm-hmm.
back then. And like one of the models that we had like placed really well
Yeah.
and got like state of the art results.
Mm-hmm.
But then right around that point of time, another data set came out, which was
Mm-hmm.
this VizViz data set, and this was
Mm-hmm.
essentially a more real world application of VQA, which was like it was like a data set where like
Mm-hmm.
blind people were walking around using their phones, pointing at stuff and asking questions about it.
Mm-hmm.
And like, when you looked at the data set, I mean, it was like collected like quite painstakingly at UT Austin and CMU, if I'm not wrong.
Mm-hmm.
But then if you look at the data set, you would immediately see like this huge distribution shift from like the original VQA data sets.
Mm-hmm.
Like, I mean, on the original VQA data sets, it's like, okay, which side of like I don't know, it was like very stupid
Yeah.
questions, right? I mean, they test the models like visual understanding, but like they
Mm-hmm.
have like no real world application. Whereas
Mm-hmm.
like the kind of questions that blind people are asking for are like, okay, when is the expiry date of this food, or like what sign is there on the remote, like
Mm-hmm.
where is the button to like power down the system,
Mm-hmm.
like very practical, very grounded. And as soon as we start evaluating like, I mean, when we started like evaluating our like soda model, it
Mm-hmm.
started like failing miserably. And so yeah, so I think that was kind of like the challenge to us. Like I think it was getting like some like abysmally low percentages. I don't remember the metric, but it was like
Mm-hmm.
very low.
Mm-hmm.
So yeah, the challenge for us was like, okay, like, how do we improve the system?
Mm-hmm.
And I think the core innovation over there was actually to use like an OCR system
Mm-hmm.
that we could extract like the text components that are present in the image,
Mm-hmm.
and then take the OCR results and plug that back into like the decoding of the model so that it
Mm-hmm.
can like copy and paste those results whenever it wanted to get the right answer.
Mm-hmm.
So I would say it's still a relatively like simple approach
Mm-hmm.
to improve, but given like a huge chunk of like the questions in the data set was based on like text reading and
Mm-hmm.
OCR, so that was like the big change that I think that we made, and essentially that's what's like the paper title is, like teaching
Mm-hmm.
models to like read
Right.
text from images.
Mm-hmm.
So yeah, I think it was a very cool experience. I mean, like to
Yeah.
work on something that maybe might have like actual real world utility with like blind people was like very inspiring to do.
Mm-hmm. Yeah, awesome. I think one other thing that we might have kind of covered, but maybe we can cover a little bit more before we get closer to the end, is this sort of concept. So you had worked on, you had sort of worked on, I want to say, MedPalm 1, as we mentioned, what MedPalm 2, MedPalm M. But you also worked more recently on MedGemini. So like this family of multimodal models for medicine with advanced reasoning. Want to maybe talk to us briefly about that and how that's a little bit different than some of your other work?
Yeah, I mean, I would say that it's still kind of like an evolution
Mm-hmm.
of like the Med Farm family.
Mm-hmm.
And I think the way to think about the Med Farm family is like these are models that are essentially trained on like a large number of like medical tasks,
Right.
but they don't have like necessarily like one intended use.
Mm-hmm.
And it was kind of like the same with Gemini as well. I mean, we had like several different tasks that we were training and evaluating on across the spectrum.
Right.
And I think the key goal for us was to show that like there was maybe like a leap from large language models, which was like the PaLM-based era, to like more like large multimodal models and like the early versions of agents.
Right.
And so, for example, to get to like the sort of result that we had on like USMLE back then, like MetQA USMLE, we had this like uncertainty guided search approach, which is like quite agentic in nature. So the model will try to like guess an answer, and then we'll use like the uncertainty of the model to figure out whether it should use search or whether it should like finalize the answer. And we did that kind of in a loop. And so like that's like an early version of an LLM with like tool call to search and using uncertainties to figure out when to use that. So I think that was kind of interesting. And then I think like the other big leaps were more on the multimodal side over there. And again, like because like Gemini was like I think very strong on multimodal reasoning,
right?
But also it had these like very long context processing capabilities, like millions of tokens. I think that allowed it to do like very interesting things. And so like not only were we getting like very strong results on like this medical imaging benchmarks, but we also for the first time were able to show very strong performance on like medical video question answering, or like taking like these extremely large EHR chunks and then doing like this needle in the haystack retrieval of like very precise information, or like doing like this multi-hop reasoning on top of like very like hundreds of thousands of tokens in the EHR. So that felt like a net new set of capabilities that we had not seen in like our MetPalm based systems. Like there's this agentic capability that you could engineer with these models, the multimodal understanding, as well as like this long context. And so it kind of like opened up like a new frontier of like applications, I would say. But I guess like where this kind of like line of work differs from what we do in the other project, Amy, that I want to very quickly touch on, is that the Amy project has like a very specific like intended use, even though it's like in research settings. And essentially what you're trying to build is like essentially like a general purpose medical super intelligence that can sit in your pocket and be like you can use it to like ask any kind of like medical questions and have like a conversation anytime that you want, and you kind of like come and give you diagnosis and treatment recommendations. So because of that, like the choices that we made in like evaluations, they were all very specific. The kind of like multi-agent setups that we had, or like the fine-tuning, or like the self-play setups that we had, they were optimized for that one task. Whereas like I would say like the MetPalm series of models or MetGemini, they were very broad. They were like going like wide, but they were not optimized for like one single thing.
Yeah, it totally makes sense. So I guess in our last few minutes here, just a few things. So number one, beyond, sort of the research at Google and Meta, like that we've talked about, you've also been involved with, SPC or South Park Commons as a member for a little while. You did some venture as a sort of a venture fellow at Help Span Capital. And then more recently, you're also a faculty at the Chan School of Public Health at Harvard. So maybe tell us a little bit about some of these sort of like side quests that you've been up to, in addition to the main quest of doing research, and just like a few of your takeaways from them, some of the things you learned.
Yeah, sure. I'm no longer like actively enrolled in SPC, or
Right.
It's been a while since like the Health Fan Capital stuff. But I think like they were quite interesting in the sense that I think SPC is like this very nice community of like very smart people,
Right.
who are essentially trying to build like the next big thing.
Yeah.
And so I kind of like met like a lot of interesting people over there.
Yeah.
And like for example, like one of my like very very good friendships right now is with like these bunch of folks who have this non-profit in India called Rocket Learning. And so they're trying to do to education what we are trying to do to healthcare. So like really like use technology and AI to advance like primary education,
Right.
Especially in like villages and rural settings. And so like I've had the opportunity and the privilege to like advise them and collaborate with them, and all those introductions came about through Subpack Commons. And Health Fan was again like very interesting because I do have like an interest in like longevity and aging, and there's like a lot of noise and hype in that space.
Right.
And like for me, like I mean, I have some experience in clinical medicine, but again, like in biology and biotech, I didn't have much.
Yeah.
And so it was like I think just being part of that group got me like a lot of exposure to what's happening at the cutting edge, like the researchers who are trying to like start new companies, and just a lot more exposure to understand like the latest and greatest in science.
Mm-hmm.
And that helped me like give like a, I would say like a proper grounding. I'm no expert over here, but I think it gave me like a good sense of okay, what's happening in this field and who I should talk to if I want like more in-depth information.
Mm-hmm.
Um, and yeah, I think the Howard one, yeah, I think that's it's just with my good friends, like Dr. Trishan,
Mm-hmm.
who's been like running this course
Mm-hmm.
for execs to get them introduced into like the latest and greatest in AI and
Mm-hmm.
medicine and science.
Mm-hmm.
And so I've been like again like fortunate enough to like join him and like I think every year if I'm not wrong, it might be a little bit more frequent. Like
Mm-hmm.
I do participate as like a faculty in these courses.
Mm-hmm. Gotcha. Okay, great. So I guess like maybe some of our last questions. So I think we've done a pretty in-depth run through of all your major projects and really exciting papers, and obviously you have a lot of really great stuff that you've done. I think one thing that is obviously really exciting these days is AI for science. In particular, with applications in medicine, I think DeepMind has done a great job, not just in healthcare, but across a bunch of different fields. Are there some specific applications within, let's first start with the AI for science sort of arena that you're interested in, and then maybe more specifically within healthcare, some frontiers that we're starting to hit. And then also, like, what do you think are some of the things that are left? So, for instance, a lot of sort of medical, diagnostics things still haven't really hit hospitals yet. Do you think that we need to collect more data in order to actually make some of this more production ready? Like, what's sort of left? Like, what's the next frontier in, both the AI for science world and then like the actual like driving adoption of this research to industry?
Yeah, I think that's a good question. So I'd say that for healthcare AI,
Yeah.
I think you're spot on there. I think like we've had like a ton of like great research, but we haven't had like enough of like implementation happening.
Yeah.
Uh, I mean, I think I would have agreed with that sentiment like even like a few months back, but I feel
Yeah.
like really now the tide has like shifted. I mean, like in the
Mm-hmm.
last week we've had like announcements from like big companies, like doing like different kinds of like integrations of AI into clinical workflows and into the products.
Mm-hmm.
There's startups like in broadly in the AI field, they're standing
Mm-hmm.
out in in healthcare, yeah.
Mm-hmm.
And like raising like a ton of capital and having like great momentum and adoption.
Mm-hmm.
So I would say like those are all good signs. I think those
Mm-hmm.
are all great signs. So I would say like maybe in 6 months when we talk,
Mm-hmm.
you will see like more broader adoption.
Mm-hmm.
But I think the real challenge is again like I think innovation tends to be like concentrated and
Mm-hmm.
like a big uh, I guess risk is like they end up like getting concentrated in like these tech forward
Mm-hmm.
hospitals or parts of like the world where like they have like the right kind of mindset. So the challenge of the question is okay, like how do you make that a little bit more even?
Right.
Uh, because again, like this technology, I think is like quite magical, and I think if you deploy it with like the right kind of like
Mm-hmm.
guardrails and like the right kind of like oversight mechanisms, then I think they can have like a lot of impact. And so the question is like, okay, I mean, it's great to like have it deployed at like
Mm-hmm.
in the Bay Area somewhere.
Mm-hmm.
Well, how do you, for example, deploy it in like parts of the world where maybe the technology stack is not yet mature, or maybe people are not aware of like what AI can do.
Mm-hmm.
But it's possible that those are the people who might actually benefit the most from it.
Mm-hmm.
And so doing that in a responsible manner, but also in like a proactive manner, I think
Mm-hmm.
that's the next challenge over here.
Great. And
Yeah.
our very last question, so clearly you've done a lot of different things. You started at Meta as a software engineer and sort of switched over to research engineering. Then you joined Google and then DeepMind with research scientists. So you sort of like pivoted more from all the way from electrical engineering to computer science to software engineering to research engineering to research scientist. So you definitely have had a career of sort of trying out a lot of different things. And so that's sort of the context for this question. Like, what type of advice would you give to just broadly engineers or researchers that are interested in sort of the applied domain? I mean, maybe medical AI, maybe even more broadly, just applying AI to any given domain. Like, what's your advice for people that are, practically AI engineers or software engineers in industry, and then maybe like for researchers that are more on the research and like writing paper side?
Yeah, I mean, I think at least for me, I feel like it's very important to have like a North Star or a goal that kind of like drives you.
Yeah.
Uh, so for me, I've been like from like a very young age, deeply passionate about like healthcare access,
Mm-hmm.
and so that kind of like drives me. I mean, I want to see that change in the world,
Mm-hmm.
where like billions worldwide have like instant access to like the best possible medical expertise.
Mm-hmm.
Um, And so I think when you have that like passion and fire and that North Star figured out, then
Mm-hmm.
I think the rest of the things like take care of themselves.
Mm-hmm.
And so it's like I think the what and the why questions are more important.
Mm-hmm.
And then the how is a matter of details. And I would even say this, like, I think like whatever form of like AI that we have today, that's a detail. And it might
Mm-hmm.
be that in future, like another technology comes around that might actually be even better, or you may want to like use
Right.
combinations, right? But that's like a detail that you figure out.
Mm-hmm.
But you need to figure out where you're going to before you
Mm-hmm.
figure out like what way you're taking. And so
Mm-hmm.
I think that is the thing I would stress like most people to figure out like what is it that you really care about, that like no matter how bad the situation is, like
Mm-hmm.
how terrible the world around you is, like
Mm-hmm.
you would still like get out of bed and like work like tirelessly and passionately towards that vision. And
Mm-hmm.
I think once you have that figured out, then everything else takes care of itself.
Mm-hmm. Okay, great. Well, thank you so much for coming on the podcast. Really appreciate your time.
So yes, thanks so much.